Hi, everyone, and welcome to our virtual road trip webinar series. I'm Molly Berry with ATS, and it's my pleasure to welcome you today as we discuss the nuances of bringing new products to market. We're joined by two industry experts who will walk us through the process of developing and evaluating products from lab design to pavement construction. Before I introduce our two experts, please turn your attention to your attendee controls at the bottom of your screen. So just a reminder, you're all in listen only mode, but if you'd like to join the conversation later, you can use the raise hand button and time permitting will unmute you. And you can type your questions into the Q&A box at any time. Today's co-pilots are Tanya Nash and Phil Blankenship. Tanya Nash is the pavement materials engineer here at ATS. Throughout her tenure in the industry, she served on many state and national committees and research projects expanding her knowledge of asphalt properties and characteristics. Tanya serves on multiple NCHRP panels, the AMAP Executive Committee, and is the Vice Chair for NAPA's Council for Engineering Research and Sustainability. Phil Blankenship started Blankenship Asphalt Tech and Training in 2017. His asphalt testing lab, better known as the BATT Lab, focuses on lab to pavement innovation. Phil is a member of the TRB Binder and Mechanical Testing Committees and serves on the executive board for AAPT and chairs ASTM subcommittee on D426 fundamental mechanistic testing. So I think we're all set to depart. Sit back, relax, and enjoy your 60-minute trip to Lexington.
Molly, give me just a moment. There's a car alarm going off, and I think we'll get that fixed here in a second. I think it's gone now, so always fun. So true to my colors here, I wanted to go ahead and put the Batman symbol up, and always a favorite childhood hero. And back to that, I want to when I was working on a name for a company, you know, I want to do something that identified, you know, my background in industry and the name, which you build a company upon, since it's privately owned, but have a little fun with it. So, you know, Blankenship and asphalt made it easy, and I'm into technology and training. So yeah, BATT Lab became very natural, which of which the name was based upon. The rest of the story is I want to especially thank the folks today for allowing this to happen. Tanya, thank you for the invitation. And Molly, thank you for all your coordination on this. I know a lot of work on your all's end to set it up, promote it, and even just the working on the ideas to make these things happen. So thank you all for doing all this. So let's get into what we have talking about today, and I know the background image may annoy some of you, so let me just go ahead and turn that off. Just having a little fun as we get into this, and these are meant to be sort of a co-pilot trip around the U.S. and appreciate that, and again, just the creativity on what you all have going on there to make these things happen. Okay, so as you all know, I'm not really Batman. I just run a humble testing laboratory here in Richmond, Kentucky, just south of Lexington, about 25 miles, home of Daniel Boone. Normally, I would say home of a champion basketball team, but for those of the friends that knows how much I love to follow basketball, there's not much to say this year. Give us till next year. Okay, let's move right on with that. Creativity is intelligence having fun. I have to work on the intelligence piece a bit, definitely having fun. But there's different versions of this quotation, but this is the one that actually was by Albert Einstein. And again, I love that. And that's up on my website. And if I'm not having fun in what I'm doing, this becomes a real work. And if I'm having fun as I'm doing it, it just becomes a part of your life, and you enjoy and you have some fun with it. One of my favorite things I like to always tell, a little bit of background about how I got into this, is when you begin to explain to people about what you do, and of course, this is a product development lab, but I've been in product development for most of my life, and especially I got the start when I was at Asphalt Institute with the gyratory compactor, working under Jerry Huber, but that translated right into when I finally, after the cabinet, I went over to work for Koch Industries. And at Koch Materials Company, or at Koch Industries, we began not only troubleshooting, but then they began and they challenged us to develop products. And I always wanted to be a somewhat of a mad scientist in a way, and be around this laboratory and doing things. I thought that's the coolest thing in the world, is to invent. As a kid, I had my I had my trains, and I had but I had my Tonka toys I played with. I was always like building roads, and unfortunately, I had a cement mixer that went by the wayside soon. But as a kid, they didn't really invent too many pavers for you to play with as a kid. So all you had was cement mixers and graders and things. But I love building. Okay, I loved erector sets, as most engineers, civil engineers would, and I love making things. And so when I got to do this at Koch, this really got to be just fun. And I realized this was going to be a big part of my life. And then working with people when that environment and the synergy that goes with it gets to be part of that. And I saw several folks on today knows exactly what I'm talking about, and a special call out there to several folks I know. I see Ian on there, but Kevin McGlumphy, we got to do quite a bit together and creating some things, and you'll see me talking about those things today. There are definitely challenges ahead. So before I get into this, I want to share with you, if you haven't seen some things that are laying ahead of us today. The most recent scorecard came out from ASCE. If you haven't seen this, I encourage you to go to that infrastructurereportcard.org and take a look. And there's different things from water quality to our schools, but you can click on roads and download. It's not a very long report at all, but it gives us a D. Now, we were a D in 2017, and we continue to be a D today. And I would say if you took a look at our roads after this winter, we would be a D minus, if not nearly failing. Here are a few facts that came from the report that's been updated. Share these with you. And it really stresses, the reason I share this is it stresses the need that we have today for new products to come in. And I'm going to share a few with you. So I can't share everything, but I want to tell you a little bit about what goes through my mind as we do this. 4 million miles. We have over 4 million miles of public roadways in the US. Okay. When you get into and you begin to look at this map, and I lived in Kansas for quite some time, roads that don't even get to show up on this are the roads. It's every square mile under the land grants that happened out there. And a lot of those are dirt roads. You want to learn how to maintain a dirt road? Go to the Midwest, look at Kansas, look at Oklahoma, look at Texas. Our nation's highways and roads move more than 72% of the nation's good. That's about $17 trillion worth of goods. We traveled 3.2 trillion miles in 2019, which was an 18% increase from 2000. Now, that's just a number of cars. If you look at the load and go back, the vehicle load that actually compares back to 1970, we have over a 700 to 800% increase in vehicle loading since the 70s on a rural interstate system. Every lane mile of road cost about $24,000 in operation and maintenance. That's not to build a road, okay? You're talking $1 million to a few $1 million if you have bridges to build a lane mile of roadway. But if you get into just operation and maintenance of that roadway, $24,000. And we're getting behind. Did you know that we're not even maintaining at the 100% level we need to be? And every year that we fall further behind, it builds up more and more. Congestion is a big issue we deal with today. And the long story on this is what we are being encouraged by the ASCE, or Emeritus Society of Civil Engineers, is we've got to fix our roads and maintain the infrastructure. We need to not worry about the congestion piece, and it's sort of like a supply demand thing. I'm not one. I believe in free enterprise. I don't like too many caps on things, but congestion can somewhat fix itself as people get frustrated and realize if there's other modes of transportation, they'll figure out how to carpool and things like that. But if we keep putting all the money in trying to fix the congestion and not repair our current infrastructure, we're going to find ourselves in a world of hurt. So we got to maintain what we have first. And then we can focus on the congestion problem. And again, that's coming from ASCE. Please download the whole report to look at it. Again, we got a D rating on our system. 43% of the system is now in poor to mediocre condition. Annually, about $1,000. I'm one of those that contributed to that last year when my son, there's a bridge out just near my house, and it has a new bridge, but it has dropped I went out and looked at it for the state and just was telling them what was going on, but it's dropped about 2 inches, and you hit that with a car tire that my son can, or one of these other places he hits, and all of a sudden you get to buy a new rim for your car and a new tire. It's costly, folks. And while the traffic fatalities have been on the decline, 36,000 people are still dying on the nation's roadways every year. Now, how does that fit into asphalt and what we're doing? Well, skid numbers, right? We're recycling wrap into these things. What's the skid on that wrap? Do we even control it? Many don't. And it's something now that we're beginning to look at. We can contribute to that, even what we're doing today. And at least 27 states in 2017 had de-paved roads. What in the world does that mean, de-paving? It means letting an asphalt road or concrete road turn back into dirt or gravel. Today, sustainability is on the move. The new administration, President Biden has said that for states to get certain amounts of money, what he is after is that they're going to have some type of component. Don't know what that looks like yet. I don't think anybody does, other than maybe Secretary Buttigieg. However, as we begin looking at what the future is, we know sustainability is in that. So at a time that we're challenged with wanting to fix cracking by reducing wrap, fix cracking by other means, we are going to have to use wrap. We're going to have to figure out, folks, how to make plastic work. Yes, I would rather not have to worry about figuring out how to put these products back in a landfill, but they're building up and building up. And roadways has been for many years, decades, the place where we do put our waste products. Even asphalt itself is a waste product from the refinery. And it because of its cost and ability to bond, it works out really well that we can use it right in the highway as a material. Again, it is a byproduct that comes from the refinery. So again, we've got to think about sustainability, but do it at a time that we do not allow the roadways to keep deteriorating. One other thing before I get into this next slide is, and I'm backing up here in here to this condition. I just heard from a good friend. And in one state, the average pavement life has declined from an average of about 20, 25 years ago, right when we were at our higher polymer dosages and before super pave, okay? And I keep in mind, back then we were also replacing roadways after a year, we were replacing roadways because of a rutting failure, things like that. So we got our roadways to last longer. However, on average, we've caused another problem, and it's one that we can maintain, okay? But we're running out of money to do this with. So the average road life or pavement life has gone from about 12 to 14 years down to 7 years, with the first signs of distress showing up in year 3. That's unacceptable. Unacceptable, especially when we have tools and LTPP bind and ways to predict this stuff. Why in the world do we do this? Well, we're in a low bid system. The good news is the government, federal government, has taken the handcuffs off of the proprietary products. However, some states are still very nervous to use those and understanding how to make that happen. So we all, industry, the suppliers, the users, and the researchers and the product development folks and so on in the test lab, we all have to work together to figure out how to get technology right to our pavements. I can tell you, and we're going to go in this next slide. Research is a dangerous word to use, and I cannot use it in my product development laboratory. I like to think of Blankenship Asphalt Tech and Training. Yes, we'll go out and do field investigation. Yes, we'll do inspection work. Yes, we'll do training. But this is an innovation lab where people they'll bring products in, and they'll want to look at these products. And I'll bring a few of these up here. And they'll ask us to look at different products and what do these do and how do they react and what are they doing. Product development's very, very different from research. Let's look at research. Research can be government funded, typically, can be privately funded, but typically research is government funded. Research looks at fixing a problem. Maybe it's test errors. Maybe it's not getting the errors out of a test. Maybe it's an issue with the product, a device or a material, and how to accept that material. Research can be investigative. How to identify stripping in asphalt pavements. How can I better predict it? Okay, what is the best crack test? How many crack tests are there out there? So they can be investigative or summarizing the findings that I just mentioned. Sorry for the typo on number 5. Sometimes there can be no real end, and we're just building on previous work. I remember, one set of findings that we got into was actually looking at the early environmental conditioning system that we were going to try to replace TSR with. Now, what was funny was we had a Hamburg device. We're going during all this testing. If it was my money, I would have said just gone with a Hamburg test. However, the money was there to say let's get the environmental conditioning test working that we didn't get working during the SHARP program. What was the benchmark? Well, we used a Hamburg wheel tracker to benchmark this test. And I'm sitting here going, why are we doing this? We as engineers, we want to get things dotted just right. And that was one of those. Good work, but very, very complicated. And again, sometimes we're just trying to build on previous work to help the overall body of research get better. And typically after research, you're going to publish it. In the product development side, it's usually privately funded by a company or even done internally. Some of the best researchers that you'll never meet may not be allowed to go to conferences, typically aren't allowed to publish papers, but they're hidden in the corners of companies, whether a hot mix company, an oil company, a modifying company, an equipment company. They're hidden in those corners, and they're used to continue to develop things for them. And intentionally, that stuff, as you see in number 6, it is not published. It is intellectual property. I remember I was asked early on when I got back into research, Phil, you don't publish a lot. And do you really know how to do this? Oh yeah. Oh goodness. Yes, I know how to do it. I just never was allowed to speak on it because again, product development is done quietly. Otherwise you go and create a patent. And Tanya, that's a whole nother discussion, whether I keep it as intellectual property or whether I decide to patent. And those are fun discussions because they don't teach us that in school. Product development is profit driven. Again, I'm trying to develop something at the end of a process. And like I mentioned in number 5 down below, the deadline is critical for profitability and even challenged to make money as you go. When are we going to get that first, we can keep spending money on testing, but when are we going to get that first product on the ground? We want to explore new areas in number 4, and we may not have much to build on. As compared in research, we're summarizing others' findings that they've already got. In the new product development area, there may not be much to build upon. A good example is a product that I got to work with, and I use these balls back here typically when I talk about the product, but a product from BASF, and where they use an isocyanate-based product. And you go and you look at isocyanate based products in asphalt and you won't find much. And so where do you start? Well, sometimes you just have to start in your own laboratory and talking and interviewing people. Again, this type of stuff in number 6 is not published and it's considered intellectual property. Necessity is the mother of invention. And I know you've heard that and we've heard that in very, very different ways. In products that I've seen out there, whether you look at Heritage's J-band that they invented to help with the distress of a pavement joint, that's out there. You may go look at the polymer industry in general. Why did polymers come about? Well, to help us have a pavement that's resilient, not only in cracking, but first off, it was to help us make it stiffer, but also to rebound in the rutting and help with adhesion and help with stripping. Why do folks, why are these bio oils coming on? Because we have issues in our current asphalt and we've got to be able to soften these grades and be able to use wrap and some of these rejuvenators and the recycling products. Why do these guys did somebody just look one day and say, hey, I've got Aramid Fiber, I want to go just move that into the marketplace? Well, ultimately, I'm sure, and I haven't asked the guys originally, but this stuff was used in concrete materials and it was used to help reduce cracking and strengthen concrete. We needed that in asphalt too. So again, necessity is the mother of invention. One thing I like to use, and I was talking with Tanya and Molly about this, and I know Tanya, you'll have some questions for me here in a bit. So if you want to ask as we go along or at the end, we can sure do that. But that's completely up to you, Tanya. A scorecard is something I used to use when I was at Koch Industries. And while we're a bit informal here, I'm going to take a drink from my a restaurant that's close to me. So anybody from the Southeast that knows what cookout is, I've got one right next to my laboratory, and it's the best thing ever. So let's talk about a scorecard. And these are some questions. And I don't have this list built out to where it will pop up. So you can read ahead or just sort of follow me along. Whether you use a number identifier on here of a scorecard of 0 to 5 or a 1 to 10 or whatever you want it to be. And you could even use a multiplier on these. I've done that before. This is something that I used to do when we had a new product. So one of the things that I worked on, and I'll bring up that product here. One of the things that I worked on back in the day and working on one of these now is an asphalt interlayer. And this stuff is, anybody knows I love playing with the interlayer product because I can take this product and I can sit here and just bend on it. And this is really, really flexible asphalt, about 100 times more flexible than normal asphalt. Kevin, we put a few of those down back in the day. One thing that's cool about the asphalt interlayer is I had to ask, and I asked these questions, and there's no particular order that's critical, but is there a need for the product? Back again, that necessity is the mother of invention. So is there a need or a category already, or will the need, or we need to better define, better identify this? A good example is, I go back and I think of and I love the idea of the J-band product. How did that come about? Well, because of our lower asphalt mixes and the cracking propensity that we have, and sometimes it was lack of joints that we would create. We ended up creating these issues and longitudinal cracking. Well, there was no product out there to do it. So those guys had to go and sort of better identify what's going on and somewhat created that. There was a need, there was a clear need, but you really had to create a new product for something that folks didn't understand. As compared to rutting back in the day, when we had highways 25 years ago that had ruts in it that were sometimes 4 inches, 6 inches deep where your car would drag, there was a clear need and a clear path to be able to do it. So rank that. If I was going to do it, I'll give you a product and I'll just do the one here. Is there a need for reflective cracking or better identified? I would tell you, yeah, there's a need for that. But maybe I would rank that about a 2 or a 3 because maybe that need is not perceived as well or as an emergency. They're going, well, I can go and seal the crack if it comes through. Okay, so maybe we give that one on a scale of 0 to 5. I'd say maybe that's a 2. And you may say, well, in my area that would definitely be a 5. For me, that I think it's a 2 or 3 nationwide. That's why you don't see folks jumping on it as quickly. Is this product, is this a modification to a current product or a new product? If it's a modification, it makes it pretty easy. So I'd give it a high score. If it's a new product, I'm going to give it a lower score and sort of penalize it a little bit. So lower is going to be penalizing it. Why is that? Because the moment you mention new product, you just entered a death spiral trying to create that category. Anybody who's ever been out there has been there with me. It may take you a year or two just to get the product down, another year or two to get a second trial for that. You may be looking at 5 years, and this is a typical timeline and proven. And this is when I'm talking about low bid work. You may be looking at 5 years then to get this into a specification where there's some type of routine, and maybe 10 years for acceptance. I go back to the interlayer. The interlayer was introduced 22 years ago, and it is just now gathering the steam that it should have had back then. Why is that? Because this ship is a very slow moving ship when you talk about government low bid systems. And we'll talk about the difference here in a moment of government industry versus private. So again, the next one is, what about on this new product? Or the new product could even be a piece of equipment that's maybe you'd use in the laboratory. So whether a material or equipment, think of it either way. But in this case, if it's a material, do I need to go modify the plant? Do I have to modify the paver? Do I have to, if I'm Kevin McGlumphy over at Associated Asphalt, do I have to go and modify my storage or the temperature? Do I have to do something? Again, if the answer is yes to that, you're going to penalize it with a lower score. If it's no, I don't have to really modify anything, give it a high score. The next thing is field support required. Oh boy, yeah. You know what? No, this is just, boy, this is easy. This is a new anti-strip I've got. You just dump it in and it works. Easy. Oh, I've got an interlayer. This is a little more complicated. How does it compact? What do the guys on the roller need to know? Is there a certain type of pavement it needs to go over? Yeah, I'm going to need field support, so I may give it a lower score. You all are probably asking at this time, why in the world did Phil Blankenship ever work on this stuff? Maybe it was because nobody else wanted to. Number 5, is it environmentally friendly, or are there safety concerns? If I have to go and turn my plant up hotter, not only do I have to do something different in the field, but now I could have an environmental concern as compared to the thing that's coming with the plastics. Now there's a sustainability aspect that becomes very important. However, we have to keep in mind, is there a safety issue in any of the fumes that's coming off? Finally, you have to ask yourself on one of the barriers, is the sales transaction the same or is it different? You go through that and add it up. And even if you have a low score, and realize it's an uphill battle, it's important for you to know that. And it's not that if I came up with my overall score, that's, let's say if I'm doing it on a 0 to 50 basis, and or a 1 to 5 ranking, or in this case, I only have 6 questions, so a 0 to 30. If I have a 30, it's a no-brainer to move forward with. But if I have something that's lower, keep in mind that may dictate your price point to be able to recover your cost, especially if there's nothing competing in the industry. And if you have created the new and better way to do something, or a complete new process, you are the one who sets that price point. And you just have to understand what the market will or will not accept. Ultimately, you have to charge the right amount to be able to recoup the cost that you've put into this. We all know if you go and used to buy things on a CD, and now it all is downloaded. But if I were to go buy a CD of Microsoft Windows, I bet you the cost of producing that CD at the bulk that they did, or the DVD that they did, was probably less than a quarter. However, at the time that I would pay for it, I may pay several $100s for the information that's on there. Why is that? It's because of the development and the time and everything that it takes to support what is on that 25-cent DVD. The same applies in our market. As I used to tell my government friends, I would love to give it away. However, if I gave everything away, the stuff you would want, the stuff you would get is not the stuff that you would want. You definitely want to pay the price and get the stuff that's good. Otherwise, I'm just cleaning out the trash out of my lab or out of the refinery or whatever it may be. Okay, the discipline of product development, of the product development lead. I want to share this because this was something very new to me. And I really, Tanya and Molly, when you asked me about this one, I really had to think about this one a bit. The thing that I've had to work on, and with my temporary employees, and even with Zach, who's the main lead in the laboratory operations manager, is that if I were to go into a standard laboratory and I go in and I just want to test a material and maybe a gravity and just measuring it, I go in there and I measure it and I take it and I throw it away. The difference is in a product development laboratory, you need a laboratory that understands product development versus this standardized QC testing. What happens in the water? Did it leave a film in the water? Did it all of a sudden absorb something? I've actually had products that actually, after it was treated with something, absorbed more water just on the gravity test. How does it react when I break it apart in a TSR test? Is there something different? Is there a smell? And so what a normal technician would never tell you, I tell the technicians here, I want to know, Zach and I want to know everything that's going on. Did it smell different? Did it look different? When you're breaking it apart, did it act differently? Does it feel different? When I go out to the field, what's good, bad, anything, my ears are wide open. And by the way, there's not a product today that I haven't heard that every time you go out and if you ask the guy on the paver, did it compact better? Everyone, oh yeah, it always compacts better. And that gets to be a hard one because then there's one thing to get the feel good piece of it, but now how do I quantify that? Again, open mind, one size doesn't fit all. And we're going to go into that here on different tests here in just a moment. And then current tests that we do are very dependent upon asphalt and aggregate relationships. So let's talk about a basic fatigue test where I would bend something. That is designed for flexible pavements. I would never do that on a rigid pavement such as concrete. But if I'm designing a flexible pavement, of which asphalt, bio products may fit in, plastics I think would fit in, I'm still dealing, if it was made with or without asphalt, it's still a flexible pavement. So that's a very fundamental test that can help me understand as I load a pavement, what is the reaction to that? How much does it move? Or if I move the pavement, how much does it want to resist? As compared to an index test, today we hear a lot about ideal CT. We hear about SCB and some of these different index tests that are out there. Those index tests are very, very dependent upon the asphalt aggregate relationship. It is based upon a viscoelastic mindset. And so if I break out of that, that may not work right. The other thing that we depend upon a lot, even in our binder test, is everything being somewhat linear. By linear means if I draw that line, if I move it so far, it goes back into that line. What about if I begin to move it and it wants to go up, or if I release it and it takes a whole different path back to its original shape? Okay, now it's not very linear anymore. For me, I mentioned already, I need to see, feel. I need to understand the material. What is its use? Sometimes I'll get asked a question, Phil, do you see other uses? Well, boy, I may have a very rigid material. I don't want to put it on a surface. Have you talked to the roofing industry? Or I've got something that may set up very quickly in a laboratory or with a two-part system. Have you guys talked to the patching folks? A whole nother issue. And again, the other potential uses, private versus agency. Agency, boy, when I blink my eyes, the dollar signs appear when I think of an agency, because I'm thinking about all those millions of miles of roadway. Look around the parking lots that's around us and the privates that are out there. If you can't, before you take it to an agency, try to do something on the local basis. Try to look at a county. Who do you talk to? Is it one person you talk to at the state? Is it always Division of Materials you go to? Not always. Your inroads there could be the district. It could be construction. It could be operations. It really depends who that product champion. And that's what you're looking for, is you're not looking for one individual. You're looking for who would be that product champion at an agency. Versus the private side, you may have a contractor that says, Phil, I'd be glad to try this. Matter of fact, if they're willing to donate some material, we'll go over here on this little roadway and try this on a county road, or we'll try this at the local what store, whatever it may be, and they don't mind us trying it, as long as your client doesn't mind to help me on the materials cost if we have to take it up. Yeah, risk, reward, right? Risk and reward. The other thing that I also said that one, and I didn't add it on here, but there's a discipline in product development that you've always got to understand and keep it in the front of you, that there's three things that's critical. It's need, it's defining the solution, and then the benefit. At the end of the day, the customer and my clients need to understand what is the need, how is your product going to help in the solution, and then ultimately what's the benefits. And by the way, I haven't seen a product yet that you come out and say, well, there's not much of a need. And we really can't add to the solution. And by the way, it reduces pavement life. If that is your product, you may want to rethink. You may want to rethink, as Jeff Foxworthy would say, you may want to rethink what you're doing, or your product may be a failure. Everything I've ever touched, the belief of the client is that there is a need, and this is how it fits to the solution. And finally, the benefit is some extension of that pavement life. Tanya, before I get into the products, are there any things there that you would like to jump in and talk about? I know sometimes it's in a two-way conversation. I tend to take up most of it. Anything that you'd want to add at this point, or you get into a lot of this too, Tanya, down at ATS, and you get into quite a bit on the product development, and you know, it's a very different life. Anything that you want to add before we jump on these stories of product development?
Yeah, Phil, not at the moment. I think I'm gonna, some of the things that I have kind of jotted down to kind of talk to you more about, or have a conversation with you about, is something that we can address after your stories. I'm kind of anticipating some of your stories, so I'd like to kind of finish out, and then we'll kind of revisit some of the questions.
Awesome. Okay, so just a few stories, and not going into too many war stories here, but keeping it fairly short. One of the when I opened BATT Lab, and some of these are older, but when I opened BATT Lab, and I cannot list all the clients I'm working with, okay? And then one of the folks down here, Macroburr, is one that they're not a client of mine. I just I know the guys, so I lifted a picture of theirs off the website because it was really cool that this road is made from plastic. But the other folks, I have permission to begin opening up that I have a relationship with them. So because when you sign an NDA, and again, this is a private company, so when I sign it, it's my word, and I want folks to come back to the BATT Lab. But one of the first ones was we had to keep very quiet, was an isocyanate based system, a modifier from BASF. Now they're growing that and they're getting it out, and naturally they wanted that market to grow quickly, but very quickly they understood that their product has to get tested. They went to one group, and nothing against that group, but one of the things they were told was, guys, it doesn't fit, and you really need to rethink your product. Well, I looked at this product realizing, yeah, it's not elastic, it's not SBS, but it's really, really adhesive. And this stuff is really, really tough. And it has a synergy that works incredibly well with current polymer systems. And it's 100% reactive, so it doesn't separate. These guys, I appreciate what they're doing. They stayed the course. They did not give up. And they're actually going to be putting some of their stuff down at the test track at NCAT, and to understand, you know, what it will do. And you have to prove it out. And one of the things they asked me, they said, Phil, how do you break this product? What's its weakness? And we had to look, and we had to dig and find out, and understand how it works in high strain behavior and high movement and low movement behavior. But again, because if we looked at that one product just in the world that we live in, we would have never have moved to the next step with it. And then we would have told them to go away. And that would be shame on us. BASF is one of the world's largest chemical companies. And we need companies like BASF bringing stuff to our industry to say, hey, we've got this. Do you think it can help? Because it's going to make our product better and help us make our roads last longer. Aramid Fiber is one. This is a fun one. I always love doing this demo. So I get my asphalt sample, Tanya, and if you look, this one is sort of put together, and I'm going to hold on to a fiber here and dangle it. But as you see on the corner, it's a 3D, three-dimensional fiber reinforcement in there. Why didn't we use them before? Well, because Superpave came along, and why don't we use Aramid Fiber like wild today? How much of the market's it in? Very, very small market, probably less than 0.01%, I bet. But why don't we use it? It's because it's Aramid Fiber, and it doesn't go into the liquid binder, and it's not a rock. So it's not asphalt, it's not a rock. And it's not a liquid modifier, it's a mixture modifier. I asked one agency, why don't we use it? And they say, because we don't know how to measure it. We don't know how to measure the mix performance. Well, that's changing today with our testing that we have. Incredible product. It's a polymer. But the other funny thing that happened is they went and they ran it in a modulus test. And the guys came back to me and they said, well, we found out, Phil, that it doesn't help modulus. But when we go to the field, we measure it, and we find out there's a 25 to 50% modulus increase, and we put it down at all these truck stops, and we're seeing cracking going away, and we're seeing structural depths that may be 8 inches that's acting like 12 inches. And here's the reports. Why is it in the laboratory? They said it doesn't work. Oh yeah, don't forget, our lab testing is a compression test. So when we check modulus, we're squeezing the fiber. Now, I don't know about you, but if you want to take advantage of a rope, you pull the rope, you don't squeeze the rope. Same thing with the fiber, you got to put it in tension. So unless you run a test, such as a pull test or a beam fatigue test to bend it, you'll never see the benefit of the fiber. Again, one size does not fit all. Asphalt Interlayer. An old way of doing it was with the high polymer system. Today, I can do it with Aramid Fiber. And again, I appreciate the clients who've come to me, BASF, Surface Tech, Georgia Pacific through the years, the Color Botics group, and even more and more newer folks that are coming this way. But the Asphalt Interlayer was one, and Kevin, you remember this one. It was an uphill battle. Why do I want to put an inch of asphalt down? Well, we can do this. We can make it anywhere. How can, what's so special about this? Well, we're going to we need performance testing. We need to be able to guarantee it. When you do that and you go, well, now it's really complicated. I just want to go back to air voids. What's the air voids of it? Well, it's 1 to 2%. Oh my goodness, we can't do that. Don't put that down. Guess what? Out of all the interlayers that's ever been down, not a one ever rutted. And average, when I left Coke, it improved cracking by over 70% over high stress reflective cracking over concrete overlays. Again, it's just the mindset of are we ready for the new, and what's the barrier to entry? We all want to get to the same place. It's just having that shared vision. And I've always said, and you've heard this, made this statement before, a vision without implementation is just a dream. No different than action without a plan is chaos. And you have to have these for these products. Bio oils, how cool are these products that's coming out today? We can't use aromatic oils, and we know what's happened with Riob and other products. The bio oils are coming like a freight train, and it allows us to modify asphalt even at the local hot mix plant or upstream, and they react or peptize. And they help soften and they help lower these grades. Incredible products. Plastics, not all of them are water bottles. Okay, we tried this before with not much good to say for what happened, because it caused cracking issues with the old products from 30 years ago. However, today some of these guys, not only can they shred it and add it in, but some of the guys are looking at low density polyethylene, the Walmart or Lowe's bags you may think about. Or PVC that's been broken down. And then it's important to segregate those so you know what you get. But also the plastics can be chemically, there's more cost to it, but chemically broken down to where they're turned back into a liquid form. So don't think of plastics as just these bottles. And folks, the plastics are coming. We just need to figure out how to make this happen. Asphalt replacements. I can't go into a lot of detail there. But the asphalt replacement is a very interesting concept. We've heard it with algae before, but there's other waste streams out there that I can take and maybe mix with RAP, or I could take instead of using asphalt at all. Now they're not a large scale, but I can take these products, these waste streams, and begin to supplement and bind things together. Again, sustainability. So you're talking about when your name is Blankenship Asphalt Tech and Training, and somebody brings you something that's not asphalt, I got to really sit here and rethink, what am I doing? Is it okay with my business? Does it align with what I'm doing? But also, is there really a place for this? And you got to be really open with your client and just tell them, I don't think it'll work, or I think it will work, but if you do it, here are the challenges. Everything will work. It's just, are you willing to put in the sweat equity to make it happen? With that, Tanya, let's have some discussion on this. And I don't know if you're allowing, I guess you're allowing participants to chat and so on.
There is no chat, but there is a Q&A. So
Q&A, thank you.
If anybody does have a question, feel free to type it in the Q&A box and we will get it addressed. Or if you like to ask it verbally, through the actual webinar, you can raise your hand and we will unmute you, and you're more than welcome to ask it freely.
Yeah, and I definitely see some folks on here who understand this process really well. I already mentioned Kevin, I see several others, and a call out to Ann. Ann, you have a new piece of equipment. You've been trying to get in the industry. What a great piece of equipment, but it costs more than doing an extraction the old way, but you don't have to touch chemicals, and barriers to entry, right? Yeah, throw those questions in there, and let's talk about this. Product development, whether it's a material or equipment, it's can be very similar.
I have a couple of notes jotted down. I appreciate your presentation, Phil. As always, a great presentation and great conversational pieces that we can kind of build on. I do have a couple of things that I want to kind of throw out there at you and see what kind of opinions you have on them. You have a slide that kind of discusses the differences between research and product development. There is that term out there of implementable research.
Yes.
Right. So the idea that you are doing research, but the outcome of it by the end of the research cycle, or whatever you deem the end, has to be able to take a step on implementation of something, a delivery of some sort. And that I would see that as kind of like the blend of the two sides of your slide.
Yeah, absolutely. And of course, you found a gray area in there, Tanya. The research side, and I'll just be straight with you. When I worked at Koch Industries, I was told pretty quick by higher ups, if you use the word research at that time #2 company in the private company in the U.S., if you use that term research, realize that there was a reason this building was vacant for 10 years before you moved into it. So use it very carefully. This is not a research building as it used to be called. This is product development. So absolutely, there is implementable research. And I do believe today, even TRB and the boards there are looking at things to be more implementable. One of my favorite ones that what I think would fit well is the new federal highways Everyday Counts initiative. They know density matters, and they did the research behind that to show if you just improve your pavement 1% on density, you could add a year life to it. And if we did that, the billions of, I think $1 billion annually is what it would save by improving our pavements 1%. Implementable research. I like that.
Well, even a step further, I know that during the NCHRP projects, they also provide funding for projects that get to an output that they need just a little extra to be able to get that implementation push, maybe some field studies, some extra things that weren't feasible within the actual project. So they do, the federal government is behind that implementation idea of viable research.
Oh yeah, and don't get me wrong, research is important. That's just not my bailiwick right now, because without research, and another good example is out of research and out of a lot of these projects, usually that's how AASHTO standards are developed, and we need those test standards. That's right.
Yeah, absolutely. Good. So, you had touched on it, and I was kind of, you couldn't see me. I was shaking my head in the background, and I was going, it's super important that companies realize that as they come through and they're doing that product development, that they do have to establish a certain degree, or the facility that they're going through has to establish a verbal written agreement of, confidentiality. That's a big deal. It being able to trust the
Oh,
people that with
yes.
you, the work that you're doing, whether it's an IP issue, whether it's, you sign your NDAs and you make it evidently clear that it is under a confidential conversation with every communication that you have. So that's one thing that I know that it's critical for, especially during a development stage.
Well, Tanya, and some of that's need to know. Like Zach knows everything here that naturally that we're working on, and I actually label it on my internal files if it has an NDA with it. And even if it doesn't have an NDA, I'm not out there talking about it. I pretty much treat everything confidential unless it's, oh, Phil, here's a data set you can share.
Agreed.
But the employees in the laboratory, by the time they get it, it's got a code on it, and that helps me with two things. They don't know that I'm working on now Aramid Fiber. Okay, it's hard to hide Aramid Fiber, right? But a lot of these other products with oils or different things that may already be blended in, if it's already been done for them, what's sort of neat is that, do you all notice anything different? And guess what? We may not have done anything different, but I'm just asking to find out. So sometimes this blind testing is important because it doesn't, you're not leading the witness when you're doing the work.
Right. Agreed.
Yeah. Thank you, Tony.
I have a kind of a general question for your advice. What advice would you give somebody that came to you, just like you have your photo of your congested street, right? We have congested highways. There's areas that are just overpacked, and they find a way out of it, find a different path. I would say that's probably true as well for the congested markets. The marketplaces for instance, liquid anti-strip is a good one. If you come up with a brand new liquid anti-strip, do people jump up and down and go, oh my gosh, we've been in need of this? Probably not. But I mean, can you use it at 0.1% rather than 0.5%? Maybe that's the big, pull on your product. So how do you normally enter a conversation with somebody that is trying to enter a massively congested market?
Oh boy. Yeah. And that one, actually, I'll bring up the fiber one again. When these guys first came to me, they brought me and I said, oh, another fiber. and they had to help me understand and differentiate that it is not cellulose fiber. It's something different. So the first thing I would ask, like on the anti-strips, is there something different about it? We all know anti-strips will react with PPA, but there's a class out there. There's a class of those esters out there that do not react with PPA. So is there something that differentiates your product? Because if it's a me too, then you're going to fall right at their price point. Right. If there's something unique, and I'll throw this one out there, the conversations lately I've enjoyed about with another potential client most recently, and they have a product and they put it in, and yeah, it's another bio oil, for instance. Okay. But it's more fuel resistant. Okay. Ooh, well, that's something special. Okay. That's something really special to understand if you offer that advantage. And so finding that niche. Otherwise, if there's nothing special, then you're just get in line behind everybody else. And then you're on a general approved list, and you're going to have to do a lot of groundwork and take a lot of contractors golfing or shooting or to the horse races to get them to buy your product.
So Phil, we did get 3 questions that popped up, and I'm going to go to Kevin McGumfries first, just because he does have to pop off right at 3 o'clock. So he says, Phil, thanks for the old school shout outs. Do you feel that the balanced mix design parameters will dictate the recipe, and or how would you suggest those specs be written to allow performance and innovation?
Oh boy, that's a loaded one. Yeah.
The $1 million question. I'm waiting, Phil.
Old school shout out to my Oh, Kevin, you got your start in West Virginia. Oh my goodness, we're both above our raising today. Yes, it will dictate eventually, but I think there's going to be a lot of hand holding. If we took all the handcuffs off of it today, and some have tried that, I think the complication really gets on the bidding side. Contractors don't know how to bid this, right? And now you have one contractor, bidding it at 6% asphalt, another one at 5.5. Both are meeting the performance criteria. Ultimately, where I think we've got to go with this is we can handhold all day long, and we're going to end up with a mess. Because if I can design, and I do think there's parameters, Kevin, that we can say, let's keep the parameters in a safe zone between 2.5% and 4% air voids. Let's make sure that if you're concerned about VMA, I don't know what the right VMA is. For one mix, it may be 15, another one mix, it may be 14, even if the same aggregate size. But let's keep everything to the left side of the minimum of the VMA, minimum VMA. Most importantly, make sure we know how it's going to compact in the field. We can do that through the gyratory that's been out there for years to predict field compaction. With that, we're going to have to take the training wheel off, and we're just going to have to say, this is a balanced mix design bid. We're not going to require stringent air voids. We're not going to require all these other things. If the asphalt content comes in at 5, if it comes in at 6, contractors go at it. Because I really believe the more we try to mandate and lock this in, it's no different than us just getting involved with a free market that we don't understand. And it's only when we're going to have to put these tests in place that we trust for now, Hamburg and Ideal CT, and get these projects out there. And I think Tanya and Kevin, when we do that, we're going to find out that something's going to fool a test, but you know what? We can't live in fear. We're going to have to move this thing forward and do it through these pilot projects and get them out there. But the more we handhold and try to do BMD with it, we're just going to make a mess.
Yeah, I would have to agree that there's a degree in there that you're just going to have to trust, I guess what you call trust the process, right? And trust in the system. Where, I mean, there are still pavements out there that fail or have distresses on them that have perfect volumetrics. I mean, so I'm not sure if there is any perfect for all scenarios.
Well, and you have to realize, Europe has done this for years, and contractors produce warranty projects over there. And again, it's a different mindset, but they've used French wheel trackers, they've used other cracking tests, and some of them pretty sophisticated. Look at what the long life pavements in the good success. Now they're slow to build and they're slow to test, but look what California's done. And those are so built around performance specifications. So we can do it, and we've done these things before in other places. We're just going to have to. It's just a matter of us doing it, and then we have a brain drain in DOTs right now, and we need to support those guys and help them keep up with the mainline information.
Okay, and a question from Anne. She's asking, how often do you see products do great in the lab setting and then fail in the field? That's a great question.
Oh, I have to say I haven't seen that often, Ann. I think of a few things, maybe with lime, when it looks good in a field on a TSR test, when you've run it on wash aggregates and you go to the field and then you have a high dust amount and you use the lime, and now it's lime on top of dust and it didn't work to help in stripping. But that's a great question, Ann. It's more often that you see it do well in the lab, it does well in the field. And I think the bigger question is, where do you set your limit? And we can split hairs all day long about, is it 10,000 passes or 15 on the Hamburg? Both of them are good. Is it 65 gyrations or 75? Okay. A favorite one, is it going to be a 90 or 100 or 110 ideal CT? All of them are better than where we are right now. And so, Ann, to your point, if it does good in the laboratory with the tests that we have today, I think we need to get it out in the field, and we need to do a few projects just to vet it, just to check it, because we can't go over. I always say let it get through a 4th of July weekend and let it get through a winter. but we've got to move that direction. Great
Yeah,
question.
great. And I would say that I would agree with you a lot in saying that most of the time it's flipped over, where it does great in the field and then you can't seem to mimic what you're seeing in the lab. And I think that's just the hurdle that we're still trying to get over of, are we really doing what the plant is doing in the lab? And that's that kind of back and forth argument of, what are we actually simulating and are we doing it properly? But really the field is really where it's at, right? That's the proof in the production and the laydown. So, all right, great questions. We do have a couple more questions, but I see Molly popped on, and so that's my cane.
You want to try to address them briefly, or we need to cut out?
We will record them and we will email the answers.
That'll work.
We'll go from there.
Yep. I'm sorry we couldn't get to all the questions. I jotted them down and we will get the answers from Phil and Tanya, and I'll email those out to all of you. So Phil, Tanya, again, thank you both so much for your time today. Thank you for the valuable information, Phil, that you supplied, and Tanya for starting such a great conversation. And thank you all for tuning in from wherever you are today. And stay tuned for answers to the questions, and a recording of this webinar will be made available. We'll send that along with the question answers as well. Have a great day, everyone. Thank you, guys.
Thank you all.
Thank you.